Okay, this is Empirical Formula Lab post-lab. One of the first things I want you to notice is that your hypothesis, there should be two equations, one for the copper sulfate and one for the magnesium oxide. One is a decomposition reaction and one is a synthesis reaction. So I do expect this to be in your report. Now, I will not be going over questions number 2 or number 3. These you're capable of looking up on your own to find out what those mean. I will be going over question number 1, 4, and 5. So, question number 1. There is an additional video that goes over how to do this strictly with the copper sulfate. I'm going to focus this one on the magnesium oxide. So on the magnesium oxide, we have our equation, and then we have our data. Now, I'm not sure how you construct your data table, but this is from a student. And so we have his magnesium, the crucible, the lid, the system before, and then the system after. What I'm interested in is the difference between these two numbers here. That difference is the magnesium oxide. Since I know that I have magnesium in here, the difference is going to represent actually the O that attached to the oxygen. Once you have that, we start with our calculation by using our 0.2 of the magnesium. This is the only number that you should really have to change. This set of numbers will stay the same because I go to my periodic table, find out that magnesium was 24 grams, and I put it on the bottom so I can cancel a unit. Then I put 1 mole of magnesium on top. When I do the math, I'm going to keep several of these numbers because of my next step. So then I'm going to do the same thing with the 0.1, which represents the oxygen. So the 0.1 divided by 16 grams, because that comes from the periodic table. This gives me how many moles that 0.1 represents of oxygen. Your next step, we compare these two numbers, the two that we just got, and we determine which one's the smallest. The smallest is the 0.00625. So we're going to divide it by itself and set it as 1. And what I do to one, I do to the other. This is giving me a ratio. That's the whole point of that. It tells me that I have 1.33 moles of magnesium to 1 mole of oxygen. Since I can't have part of a magnesium molecule, then I'm going to round this based on my rounding rules. And for this team, this becomes 1 magnesium to 1 oxygen, or they have 0% error. If you do not get a 1-to-1 ratio, then you will have to actually calculate your percent error by taking your molar mass and you'll take that and use that for your percent error. Question 4 and 5. 4 asks you for the theoretical yield of magnesium. So this is our reaction stoichiometry. Again, we're going to start with the 0.2 grams of magnesium. This step is the same as we did a while ago. 24 grams to 1 mole. This is our new step. This step comes from our equation. I look for magnesium. It says 2 mmg on the equation, so I put it here on the bottom. Then I look to my MgO. It has 2 MgO, and that goes on top. Then the last step is the same as what we've been doing. So since I have moles on top, I got to put moles on bottom. And then I got to get what my molar mass of magnesium and oxygen is. So I add up my parts and I get 40 grams. Then I'm going to do my math. 0.2 times 1 times 2 times 40 divided by the product of 1 times 24 times 2 times 1. I get 0.33 grams. This is my theoretical, or the max. Percent yield. Question 5 is actual over theoretical. So when we did this, our actual was 0.1. So we're going to put 0.1 on top and 0.33 on bottom. Then we're going to times it by 100. Notice we get 30.3%. So we did not obtain our theoretical yield. So even though we produced almost a 1-to-1 ratio between the magnesium and oxygen, we only got 30%. Don't forget to your post lab. A few notes. Empirical molecular formulas. So empirical formula is the simplest whole number ratio of an element in its compound. A molecular formula will be a multiplier of that. So empirical formula does not necessarily identify what I'm working with, but a molecular formula will. This is notes over how to do the calculations, the one we did for question number 1. Percent error. Again, this is just showing you, reminding you how to calculate percent error. This is percent yields formula. Hydrated and hydrosoaked. Again, it's in the PowerPoint for you guys. Anhydrous, and means without, so it does not have water molecules attached to it. Hydrated salts have water attached to them. Notice, this is what we did for our lab here. There's our copper sulfate after we dehydrated it, and there it is with water again. Extra notes just reminding you about a mole and what a mole ratio means, and reminding you about your molar maps and how we move from one to the other. We will begin using Avogadro's number soon. And just some old notes about solubility, just keeping that going, and solubility rules and tricks because we're working in that area. Chemical equations, still working with our 5 types of reactions and how to identify them and what our products and reactants are. Coefficients, subscripts, and formulas. And a reminder about our balancing equation rules and how we balance them. Every day we get better. And just some more notes over some old stuff. Your crisscross, your metals, your polyatomics. Properties, physical, chemical changes. Okay. That's your post lab. Good luck. Great job.